Wheatstone bridge. So have you heard this? So you take some resistance like this, some resistance like this, some resistance like this, some resistance like this. You connect it through a battery cell. Okay. Let's say I connect a galvanometer of this. So let me take this as P, Q, R, S. I think your book may be giving it as R1, R2, I don't know, so it doesn't matter. So it's just a representation for resistance. Okay. So let's say the current is flowing from here, right? So this is only battery. So current is flowing here. So I. And let's say as soon as it comes here, what will happen? Let's say 10 liters of water is coming here. So what will happen here? 5. It depends upon the resistance, right? If the resistance here is more, maybe this will go only 2 liters. The 8 liters will go here, right? So that means this is going to be, let's call it as I1, this is I2. Okay. And I am going to say in this particular condition, so make this arrow straight here. So in galvanometer, if the arrow is straight, what does that mean? Zero deflection, right? So if it goes on one direction, right? I have a galvanometer here, I will show you later. So if it goes on one direction, the current is flowing in one particular direction. If it goes on the other side, it's flowing on the opposite direction. That's the meaning. So that's why, sometimes when you want to detect current and you don't know which way the current is flowing, you use galvanometer. Okay, so that's the purpose of galvanometer. So which means if I say there is no current flow here, whatever water is coming here, it's going to go here. So that means this will also be I1. Whatever is coming here is going to go here, I2. And here it's going to be again I1 plus I2, right? So already I have given you the condition. So when zero deflection in galvanometer, this is my G, it means zero current. So I'm going to take this as loop 1, this as loop 2. So can you write the equation for loop 1 and loop 2? So let's say I'm starting from here. Is there any battery here in this loop? No battery, so what should I put? 0. I1 into P, because I'm going in the same direction. I'm coming here. Is there any current here? Nothing, right? Even though galvanometer has got some resistance, there is no current here. So that means I don't have to worry, because 0 into this, anything is 0. Come here. I2 is coming this way, I'm going this way. What should I do? Minus I2 into R. So minus I2 into R. That's all right, nothing else. Do the same thing for loop 2. Can you do it yourself? Is there any battery here? 0. I2 into S. This can be written as I1P is equal to I2R. This can be written as I1Q is equal to I2S. If I divide equation 1 with equation 2, right, what do you think will happen? I1 can be cancelled, I2 cancels, so what do you get? P by Q is equal to R by S. So it's a very important formula. We'll be using in all the Wheatstone problems. So what is the condition? The given condition is there is no current in this bridge. If this is the case, then this by this is equal to this by this. Okay, so make a note. So when we say bridge, we are talking about this bridge. That's the name, Wheatstone bridge. So when current is 0 in the bridge, then this condition satisfies. So I have connected, except for this, right? I have connected all these things. So it's this red is coming here, it's going through this R, right? And then from R it's going to the S, from S it is going back to the battery. And from here there is a T connection. So from the T connection it is going to the P, this is P. And then from the P it is going to the Q. And then the Q is coming and joining after this S. Okay. So if you have any trouble seeing it, maybe you can come to the front. Okay, it's up to you if you are interested. So then I would like to put one more bulb here. So here from the P, right? So this is my P here. So after the P I have to connect a T connection. From there it has to go through another bulb, and then it has to go between R and S. Okay. So after the P is this one, right? So it goes to this bulb here, and the bulb is getting connected over here. Okay. So you see I have connected this, but it's not glowing. Any idea why? So I connected this same way. There is no flow of current. Okay, very good. Why? No, he is coming to the point, right? Step by step, you have to think. Why are you laughing? So he is thinking. So why do you think there is no current flow? What can you say about these bulbs? Are they different or same? Same. So if the resistance is same, what can you say? P by Q is equal to R by S. So all these things are same, which means it will be equal, right? So that's why it is satisfying the Wheatstone bridge. So that's why there is no current flow between this point and this point. Okay. Or I can tell you, I can show you one more interesting thing. When do you think there is no current flow? When do you think there is no water flow? And the level becomes 0, right? So when the level is same, there is no water flow, right? So you can look at this. So suppose if I put across this point and this point, what is the voltage? 1.5. Okay. So if I put across this and this, 5.7. So now look at this. I am putting my leads between this point and this point. So look at this here and here. 0. So there is no potential difference. So since there is no potential difference between this point and this point, there is no current flow. Okay, so that's the concept. Why do you think there is no potential difference? Because of this particular ratio. So because of this ratio, the potential at this point and potential at this point, already we talked about it, right? You know what is potential at a point and potential difference between 2 points, right? You know the difference. So that means the potential at this point and potential at this point will be same if this is the case. If the potential is same, there is no current flow. Okay. So make a note. So if I give you a point like AB, right? Of course, it's not usually it's not given in your books. It's only for your understanding. AB points are at same potential difference. So there is no current flow. So So that's the reason why there is no current flow. Yeah. Yeah. No, when you say loop, you are talking about a closed loop. So which means I have to think only this one. I should not worry about all others. So don't worry about all these things. Just look at only this one. When you talk about this one, don't worry about this one. Only look at this one. Okay. So Kirchhoff's law is applied in the Wheatstone bridge using this, right? So if you are asked to derive this, you will have to draw this and then derive this. Very simple. Not very difficult. And the Wheatstone bridge can be applied in the next level. That is your meter bridge. So let's quickly talk about that. Can I erase this? So each one is interlinked. So from here you go to this one, and from there you go to the meter bridge. Okay, I'll show you. I have the